In this session, I want to discuss the idea of a function as a first-class object. Now, let's suppose you're learning Python from scratch. You're going to be covering things like strings, integers, lists, tuples, sets, etc. Now, all of those different types you're going to be working with can be passed around, printed, stored in different ways, passed into functions, passed out of functions. Those are what we call first-class objects. So they're things that can be dynamically created, and basically all of those different objects will share effectively the same rights. Now, one of the kind of interesting things about Python is that functions are effectively first-class objects, meaning that they share the same rights. So they can be passed around, printable, we can store them in data structures, we can pass them as arguments, we can also return them from functions. There's a whole lot more you can do with functions, which effectively kind of make them look like and behave just like any other normal data type in Python. So in this video, I want to go through a couple of sort of different interesting use cases just to prove how functions are first-class objects. So I've got my two functions down here, got double and triple. They both take in x and then just return x doubled or x tripled. So let's do passed around firstly. Now, what I mean by being passed around, let's suppose we said, okay, I don't know, my var is equal to double. Cool, that sounds good. Now let me just try something. Can I print double? Let's see. We get a function double at this here. So this kind of shows, yeah, they're also printable as well, which is quite cool. Now let's also print my var, which is this guy here. And check this out. Because we've said my var is equal to double, we print off double, print off my var. The output of the print is exactly the same. This here is actually referring to the memory address. So the first one from double, yeah, it lives at this kind of hex address here. When I print off my var, exactly the same thing. So what that kind of means for us is, if I did print my var, let's do 10, like this here. There we go, 20. So this is proving that our functions can be passed around and they're printable. You know, like if you had a list and said, I don't know, A is equal to 102, 300, etc. like this, and then did, I don't know, B is equal to A. If we then did something like B dot append, let's just do 10, and then go ahead and print off A, we get the same thing here. So in this case here, I'm passing around this list to different variables. So if we do like B dot append of 10, yeah, then when I print off A, we can see the results of this just happening somewhere else, which is quite cool. Basically the same thing is true for my function here. I've said, okay, my var, this new variable, is going to be a reference to double, which is a function. That now means that my var basically has all the same rights and it's going to behave exactly the same as the thing I've assigned it to. So yeah, in this case, my var of 10 is basically the same as doing double of 10 like this here. There we go, we get 2020. So this is calling the original function. This guy here is then calling a reference back to the original function. So pretty simple, passed around. One thing that is kind of cool as well, actually we can kind of cover stored in data structures as well at the same time. Let's say funcs is equal to, let's do double, let's do triple here. So we have a list containing my two functions. Let's go ahead and print off funcs, clear the screen. There we go, look at that, function double. Maybe I had to go to funcs of 0 here. So if I do this now, it's going to complain. Let's see, well, if I did the calling like this, it would complain. Okay, yeah, double missing one required argument. Suppose I then did 5. So in this context, I can, in this case, go into a list, go to the first item in the list, which is a reference to a function, and then call it like this here. So it doesn't matter like how we access it. All that matters is we end up calling it correctly when we do access it here. One thing as well we could do, if I did for function in funcs here, so just like how you might iterate over a list and print off the stuff along the way, we could do print func, let's say 100 like this here. Hit run again, 200, 300. So what's happening in this case, our list contains references to these functions, double and triple here. We're basically now saying for each func in my function, so double, then triple, go ahead and call the function we're currently iterating over, or iterating at while seeing it, pass it 100, and so in this case we get 200 because we look at double first, call this guy, good to go, We then go to triple, pass 100 to triple, get 300 back, and then we're good to go as well. So just another example as to how we can treat basically a function just as kind of anything else. Like, you know, if I put 10 here, obviously it's going to complain, but let's just try it. Yeah, so 200 calls a function, 300 calls the function. Of course, in this case here, we've done 10. Obviously, we can't call 10. 10 is not a function. So yeah, that's why this guy fails here. So let's remove this and take a look at our last two. So we can pass them as arguments. Let's say, for example, def func handler, like this here. Let's say func, and let's just do value like this here. And then we'll just say, actually, we'll leave the type in for now. And then let's do the following. Let's do return func value like this here. So quite a few things going on here. This is assuming that whatever func is can be called, and then, yeah, it's going to pass in the second argument, which is value here. So if we did print func handler, okay, it wants func there, so let's do, I don't know, let's do double, and let's say 75. Let's hit run, and we get 150. Cool. What if, let's say we did something like this here. Okay, int object's not callable. So maybe you wanted to do this situation, you wanted a kind of a function to handle calling other functions. What you could do if, let's say, callable func like this here, then go ahead and do it. Otherwise, I don't know, let's just be lazy for the time being and say return -1. So if we just run this again, we get -1 because 10 has gone in, 10 is not callable, so therefore we aren't going to go ahead and try and call it. We'll return -1 instead. Or if I pass triple to this function, this line's going to say, yeah, triple is callable, so therefore call it with whatever value is. So in this case, I would expect this to work. Yep, 75 times 3, 225, and that looks good to go. We can also return them from functions as well. So if I remove this for a second, let's just do, I don't know, return, or let's do double, or triple like this here. And let's just say this takes nothing. What we could do though, let's just say from random import randint like this, and then maybe inside here let's just do num is equal to randint between, I don't know, 1 and 2. This will be 1 and 2 inclusive of. So let's just say, for example, if num is equal to 1, let's do return double, or return triple like this here. So now if I then come down here and do print return double or triple, make sure we call it. Now this should, okay, we got triple, triple, double. So in this case here, we're returning, or in this case, depending on what the random number is, we're either going to return the double function or the triple function. So this function, just like how it can return a number or anything, yeah, can return functions as well, no problem at all. So now if we do this here and say 100 at the end, let's run this again. Okay, so it did 300, because in this case, let's see, yeah, this would have been 2, so it's not done this one, it's done this one. Return the triple function, and then this has basically returned the triple function here, and then this 100 then being passed to triple. Let's try it again, see if we can get the double one. And there we go. Yeah, so just proving that a function can be passed as an argument, like we saw earlier. We can also, just as we proved here, return them from a function. So again, fairly short video, but just some stuff to think about. Functions of first-class objects. You can assign them to other variables, you can pass them around, they can be put into a list and looped over. You can pass them into functions, you can pass them from functions, you can store them inside lists, dictionaries, sets. Yeah, there's a whole lot you can do with functions. I think if you're learning Python from scratch, it's worth thinking of functions like this kind of right from the offset. They're not these objects that should be seen as vastly different from everything else, because to a large degree they're just the same as your other kind of day-to-day things like lists, sets and tuples. Obviously there's different methods and different attributes and they behave in different ways, but the fundamentals of how they're used, like being passed around to and from functions, stored in stuff, printed, redefined, etc., they behave just like everything else. So that's what we mean by when we say a function is a first-class object. If there's any use cases you think I've missed here, or anything else that you think is worth covering, feel free to let me know in the comments, and I'll get back to you as soon as I can. Cheers for watching, guys, and see you all in the next video.